All right, question number 25 from ray optics, almost a very straightforward question. See, it says a plano-convex and a plano-concave. Now, this is the plano-convex, this is the plano-concave, and the radius of curvature, of course, that's a common boundary, and one has the refractive index mu1, other has refractive index mu2, and we need to calculate the effective focal length of this. Okay, now for the first one, see, I can show 1 by f1 is mu 1 minus 1 into 1 by r. And for the second one, if I see 1 by f2 would be equals to mu 2 minus 1 multiplied by minus of 1 by r, using all those stuff of the lens maker's formula. Now, you can also visualize this as the two lenses, a series combination of one another back-to-back combination, and we know the net focal length would be 1 by f is 1 by f1 plus 1 by f2. Now here it is, you have the value here, you plug it and you calculate the value of f. So very straightforward, you would get option number 3 as the correct option for this question. Now it's time to move to the last 5 questions. Let's see. Electromagnetic wave. Now say my sentence is coming true. Those topics, those areas which are specially reserved for JEE Mains are finding occurrence of the question. Now this is the electric field, and on the basis of this electric field, we need to find the magnetic field, the corresponding magnetic field. The properties used we'll see in the course of the numerical. So what I'll do is that I'll be writing the value of electric field, and that was E naught cos kz cos omega t I cap. That's the electric field. Now from this I need to find the magnetic field. What I'll do is that I'll just make a slight bit of trigonometric variation, and that will be E naught by 2 cos kz minus of omega t I cap. That's how it goes, the first part. And the second part is going to be plus of E naught by 2 cos kz plus omega t I cap. So I got the electric field here, the same thing that has been split into 2 parts. From this, we need to calculate the magnetic field. And you know, when it comes to the amplitude, see, E naught by B naught is going to be C. So what I will write is, say, if I write the magnetic field part, now this is going to be something like this. The magnetic field would be, if electric field is given, then magnetic field can be easily calculated. I'm talking about the amplitude. The magnetic field amplitude is electric amplitude divided by C. Okay, so that will give me E naught by 2C. Moment I do this, now I'm going with the magnetic field part. Let's try to see how it goes. Now, you know, in terms of phase, it's identical, but yes, the direction part has to be done. Now just try to see the phase part, cos kz minus omega t would be there. Now just think, the electric field is in positive x, the wave is traveling in positive z. So this component of the magnetic field has to be in positive y. And for here, let's say, the same thing, that will be plus of E naught by 2c. The electric field is in positive x, the wave is traveling in negative z. That means the magnetic field has to be in the negative y direction. So that will give me cos, the phase part will be same, plus of omega t, only for the difference, this will be minus of j cap. So I got the magnetic field, and a slight bit of rearrangement again. You just try to condense it. When you do that, option number 3 will come out to be the correct option for that. A slight bit of modification, but yes, quite a nice question. Now let's move to the next one. Question number 27. meter bridge, the experimental part associated with current electricity. And all of us should note this thing, especially for the future aspirant. Any topic related to experiment in any given chapter should be taken with great attention. Now, meter bridge, the resistance box, the unknown one, since it's been said the meter bridge, so this is 100 centimeter. And for different value of resistance, the length has been given here. And what we need to find is that which of the reading is inconsistent. Let's try to see. And we know the meter bridge works in the principle of balanced with stone. So what I can say is that R divided by X, the resistance box R by the unknown resistance would be L upon 100 minus of L. And now, say in all the hit and trials, the R has been given and the L has been given. So what you can do is that, now inconsistency means it could be in any given form. So all we need to do is that we need to find out what sort of inconsistency it is. So step by step you go, 1, 2, 3, 4. For case number 1, for this R, plug the value of L. For case number 2, for this R, plug the value of L. So in all the 4 cases, you will get the value of X. And, there would be slight amount of variation because of all those fluctuations and the errors associated with. But there would be one value, and that is given by option number 4, which varies substantially. You do it and you'll find that the value of X which is being calculated from 1, 2, 3 are very close to each other. But the value of X that comes from option number 4 will be very much different. So we say option number 4, you see, is inconsistent with all the given reading. Fine. Now let's move to next question.